those of you that were with us last time, you were asking me to provide you with questions that you could go away and go and practice things that we'd done in those lessons. So these were the questions that I put up at the end of the last lesson. And I said to you that at the beginning of this lesson, I would give you the answers. Okay, so I've done A in blue, B in pink, and C in green. All right, so at this point, what you guys are going to have to do is take screenshots. Okay, so I think take a screenshot now. Let me see if I can move that up. If I just go up one more. Okay, it's unfortunately it cuts up some of the top there. All right, so that's how you would have done question A. That's how you would have done question B. Here's the bottom bit. Over here, you can take another screenshot now as well. And then have a look at that, because those are the answers, and just check that you got the same answers. And then I'm going to scroll down to question C as well. And then you guys can take a screenshot. I don't think there's going to be enough time for you to copy everything down. Let me just go down to this question over here. And that was question C as well. Okay. All right. So hopefully that's been enough time. Have you all managed to get screenshots? Thumbs up, thumbs down? Anything? Want me to go back to A and B? Are we all good? Thank you. Faheen, I changed your name. I don't know why it's still calling you Lenovo. That's weird. Let's go back here and go and have a look. Just have a look in the chat. I'm sure in the participants, I'm sure I changed Faheen's name from Lenovo to Faheen. Okay, Aura's okay. Please go back to A and B. All right, there we go. So there's the top part. You're probably going to have to do 2 screenshots here. All right, so there's A and B. And then I'll scroll down a little bit so that you can see the bottom bit of it again. Okay, so I'm going to scroll down now, and there's the bottom half. Okay, of questions A and B. So hopefully those went well for you. You were able to answer these questions. These are the sorts of things that they're definitely going to be expecting you to be able to do in this particular topic. Okay. All right. I think we are good to move on. Is that right? No problem, Nolwazi. It's a great pleasure. All right, so yeah, try those. And then if you've got any questions, then in the beginning of the next lesson, we can always try and discuss them. Okay. All right, so I'm going to move on now. Our next topic is actually Euclidean geometry. It's a pleasure, Dorcas. No problem, anytime. So this is actually what we're going to be focusing on today. Now, I know a lot of you are still busy with functions and inverses. Functions and inverses are a very, very, very small part of the final paper. I mean, you literally in trials and end of year exams, you're looking at anywhere sort of between 5, 7, maybe 8 marks on inverses, so it's not a big section. Functions is very important, but they're not going to do grade 11 functions with you again like they did last year in grade 11. So it's important that you keep up to date with that. And then obviously we will be running courses through the year where we will be revising all the sort of topics you need to know for grade 11, like functions, et cetera, that you're not going to be taught again. So what we're going to be focusing on for the next 3 weeks, and you guys will catch me up very quickly, because you won't spend too long on inverses, is circle geometry. All right, and in grade 11, we do 2 new theorems, which we will be talking about only next week and the week thereafter. But it's really important that you understand your grade 11 circle geometry. So this lesson is a revision lesson on the basics that we are supposed to know from grade 11, because of course our grade 11 work is our easier work in grade 12. Okay, and I know circle geometry is something that a lot of us struggle with. Okay, so today's lesson is nice and gentle. What we're going to be doing is we're going to be talking about how we use these theorems to solve different kinds of angles. Okay, and then next time that we meet one another, which will be on Thursday, we're going to talk about how we use the theorems to prove things. Okay, so prove something is a cyclic quad, or prove angles are equal, or prove lines are parallel, etc., etc. Okay, so what I have for you here is a summary of all your grade 11 Euclidean geometry. And what I'm going to do is I'm going to move down, and again, you can take screenshots, or you can come back and come and watch these videos again at a later stage. I've typed everything up for you. So this just explains what you're already supposed to know. All right, so if you recall, Euclidean geometry in grade 11, the circle geometry, is sort of split into 4 basic sections. And the first section are the chord theorems. There are actually 3 of them, but the third one almost never, ever comes up. So we really just need to worry about the first 2. Okay, so this might ring a bell from you, well, hope it rings a bell for you from last year. If you are given the center of the circle and they tell you, right, over here at the bottom, that M is the midpoint of AB. All right. What does M is the midpoint of AB? What does that mean for us? It means that AM equals MB. This is very important. This is the information that is given. They are telling us that AM equals AB. So this line segment over here equals that line segment over there. What does that mean for us? It means that OM is perpendicular to AB. So in other words, at OMA or OMB, there is a 90-degree angle. So if we are given the midpoint, okay, or told that AM equals MB, we can then conclude that there is a 90-degree angle, and our reason for this is line from center to midpoint of chord. Line from center to midpoint of chord. Okay, the second chord theorem, we have now this is a converse of the first one, we have been given this 90-degree corner. So in other words, we are given that OM is perpendicular to AB, or they tell us OMA or OMB is 90 degrees. What does this mean for us? It means that AM equals MB. If we are using this as a reason, okay, so in other words, the diagram comes with a 90-degree corner, we use the reason line from center perpendicular to chord. So when we are given the 90-degree corner, oh, that doesn't look very nice at all. When we are given the 90-degree corner, we say line from center perpendicular to chord. So we use the word perpendicular when we are given the 90-degree corner. Okay, so a lot of students get very confused with these because they are so very, very similar. So again, what I'm going to do is I'm going to do an example with you, and then I'm going to let you guys try one on your own. Okay, so the first one that we are going to have a look at is this one over here. Maybe I should make it a little bit bigger. All right, let's have a look at this question, and then I'm going to show you how we need to set these sorts of things out. They tell us, very important, so the first thing that we always do when we're doing geometry is we don't look at the picture. We've got to read the information that comes with the picture, and we've got to pick up on key words that are important to us that we can link to theorems that we know. So they tell us that O is the center of the circle. They tell us that EO is √3. They tell us OF is equal to 2. And they tell us that OE is perpendicular to DF. So it comes with the 90 degrees. You have been told that angle OEF is 90. Okay. What do they want us to do? They want us to calculate the length of DE. Okay, so DE is this bit over here. All right. So now you have got a right-angled triangle. You know the length of EO. You know the length of FO. What can we apply in right-angled triangles if we've been given 2 sides and the third side is missing? What can we use? I'm asking you now. You can pop it into the chat. There we go. Fantastic. The theorem of Pythagoras, 100%. So the theorem of Pythagoras tells us that the 2 sides adjacent the right angle, when I square them and add them together, it gives me the square on the hypotenuse. Okay. Bontle, try That's it. So try logging out and logging back in again. Or maybe you, Linda, you can just tell her that in the chat because she obviously can't hear me if she can't hear. All right. So we are going to say that EF squared plus EO squared is equal to FO squared. All right. And we are allowed to abbreviate that and just write Pythag. Now we want to go ahead and go and substitute. So EF, we don't know. Do we know EO? Yes, we do. We know that it is √3. Do we know FO? Yes, we know that it's 2. So that means we can solve for EF squared. So EF squared is going to stay on one side. And I'm going to take this term over to the other side. So 2 squared is 4. And when I square the square root of 3, 3 is not going to change. It's just going to change its sign when it goes over. So that means that EF squared is going to be equal to 1. And now I can take the square root on both sides. And that means that EF is equal to 1 unit. What's important for me here, right, is that DE and EF are the same. Remember, if I have been given the right angle, just like I was in this diagram over here, I was given that right angle, I can conclude that AM and MB are the same. So in the same way, I have been given the right angle over here. So I can conclude that DE equals EF. So that's going to be the next thing that I write. I'm going to say here that DE equals EF, line from center, perpendicular to chord. So therefore, DE is also equal to 1 unit. Okay, so now I can see there were a few hands that went up. No, so you're not going to be penalized if you don't write the word units. Okay, I'm just writing it because we're talking about distance. Okay, let's see. Okay, that's fine. All right, are there any questions? I see Atlechang, you've got your hand up. Go for it. Atlechang, you're welcome to ask. Atlechang, you can unmute.
Can you hear me, ma'am?
Yes, I can hear you. Go for it. What's your question?
Yes, ma'am. I'm just asking here because you said we use the theorem of Pythagoras.
Yes.
When we look for EF. So I'm asking if, what if I join the line from O to D and use the theorem of Pythagoras again? Is it going to still give me the same answer?
It's going to give you the same answer, but you are not supposed to be doing any constructions. The only time that you do constructions in geometry in caps is when you are proving a theorem. So you're not supposed to, and then if you did do that, you would have to say that you have joined O to D, and that OD is a radius, and therefore, because radii are equal, that OD is also equal to 2. Then you would have to state that angle OED is also 90 because of adjacent angles on a straight line, meaning that the new triangle that you've created is right angled, and therefore you can do the theorem of Pythagoras in it. And only then would you be able to start on DE squared plus EO squared equals OD squared. So you would be creating a lot of extra work for yourself that wasn't necessary. Okay. All right, no problem. It's a pleasure. And then I see Hlogi, you've also got a question. You're welcome to unmute and ask, Hlogi.
So if you cannot unmute on your side, it's also okay for you to write your question on the chat. We'll definitely be aware of that, like the teacher Leah can continue.
Okay. So now what I want us to do is go and have a look at, so in this particular question, we were given the right angle. Now let's have a look at question D, all right? Are you told that OE is perpendicular to AB? Are you told that? Okay. The answer to that is no. We do not know that there is a right angle. Okay, there is no, we have not been told that there is a right angle over here. We've been told that AD equals DB. That's the little bit of information that they have given us. So again, if we go back up here and have a look, we can see that it is this situation here on the left-hand side, where we've been given two line segments are equal, and we then have to conclude that there is a right angle over here. Okay, so we're going to be using line from center to midpoint of chord in this particular situation. So let's just move over and go and have a look at this. Okay, they tell us that AB is a chord of the center, with the circles with center O. The other important piece of information that they give us is that OE bisects AB. OE bisects AB. What does the word bisect mean? The word bisect means? That's it. Okay, quite right, Charlotte, quite right. Samaswazi too. So to bisect something means to cut it in half. All right, and if something's been cut in half, it means that the two pieces are going to be equal to one another. All right, so this is them telling you that AD equals DB. Okay, so in other words, what this means is that AD equals DB. They tell us AD is 12, they tell us ED is 8, and they tell us that OD is X. Okay, so this bit over here is 8. This bit over here is X. And this little bit over here, let's just use a different color. We'll use pink. That bit over there is 12. All right. What do they want us to do? The first question asks us to determine the radius OB in terms of X. So when I am asked to write something in terms of X, it means that I'm writing an expression for something, but I've got variables in it. Let's just see what you guys are saying in the chat. Okay, perfect. So in other words, all right, if I say to you, here is a triangle, all right, and I tell you that that side and that side are equal, and this angle is X and this angle is X, how can I write this third angle up here in terms of X? All right, so if I had to write this third angle up at the top here in terms of X, let's say A, B, C, I know that if I add A and B and C together, I'm going to get 180 because the angles of a triangle add up to 180. So angle, sum, and triangle. So I'm just showing you what we mean when we say in terms of X. So now if I go and sub in, I don't know what A is. I know that B and C are both X. So now I can take those X's over to the other side. So A is going to be equal to 180 minus 2X. That's what we mean when we say in terms of X. So I have written A here in terms of X. Okay, that's what the question in number one means. They want me to write down the length of OB in terms of X. Now, what do we know about all radii? All radii are Let's have a look what you guys are saying. They are all equal. So that means, matrix, that OB is the same length as OE is the same length as AE. All right, they're all the same length. So all of those in yellow are radii, and they are all the same length. The only one where we can see where there's an X is OE. And we know that this bit from O to D is X, and the bit from D to E is 8. So those are the two figures that we need to add together. All right, so we are going to say here that OE equals OB because they are both radii, and that makes them equal in length. OE is X plus 8. So therefore, OB is also X plus 8. All right, how are we feeling at this point? Thumbs up, thumbs down? Is this making sense? Let's just check in with you guys. Okay. Thanks, Amaswazi. Thanks, Nobasutu.
They're really, really doing well. And yeah, more practice is
Well
coming.
done.
You guys are going to get this.
You are. You are indeed. Okay. All right. I'm so glad that this is going well for everybody so far. Good. Okay. So I'm just going to go slowly. Cool. All right. I'm glad everybody's feeling good. Now they say to us, hence calculate the length of the radius OB. All right. So hence calculate the length of the radius OB. So they actually want us to work out the length of the radius. So whether we work out the length of OA, OE, or OB, it doesn't matter because they're all the same length. Okay, but the only one that we know anything about, well, mind you, we know something about all of them. So we now know, and we can put it in there, that OB is equal to X plus 8 in length. All right. Now, the next thing that we need to do is if they want us to calculate the length of OB, calculating the length of OB means we need to solve for X. Otherwise, we need to work out what X is. So in order to calculate the length of OB, we need to solve for X. And then we can add 8 to X and we'll know how long OB is. Now, again, in your chord theorems, the theorem of Pythagoras is very, very important. They have told us that AD equals DB. What does that mean about this angle over here, the one where I'm putting the red dot? Okay, if they've told us that AD equals DB, what does it mean about the angle with the red dot? This angle over here. Absolutely, Zamaswazi. So now we cannot use the theorem of Pythagoras in any other triangle except for a right angle triangle. So if we have not been told that the triangle is right angled, we first need to prove that it is before we do the theorem of Pythagoras. Okay, because if we were to do the theorem of Pythagoras in a triangle that wasn't right angled, that would be a breakdown of maths and we would get absolutely no marks. Okay, so the idea, another thing that makes geometry a little bit more difficult is because there is an order in the way in which we need to do things. So think about it, all right? When you get up in the morning and you're getting ready to go to school, all right? You don't go to school first and then put on your school clothes. All right, you first get up, you maybe have a shower or a bath, then you put on your school clothes. All right, so if you're going to eat breakfast in the morning, you're not going to go and brush your teeth first and then go and eat your breakfast, are you? So we do things in an order that makes sense to us. We first need to establish certain things are true before we can continue. Okay, so just like in real life, there needs to be an order here. If we do not know that the triangle is right angled, we first have to prove that it is. And then once we've done that, we can do the theorem of Pythagoras. So this is not meant to be too difficult. Right? We're going to prove that that's a right angle. So we're going to say here that angle BDO. So in other words, I'm looking at this triangle over here. Okay, the one that I've colored in yellow. All right, because I also know that DB is 12. So angle DBO is equal to 90. Line from center to midpoint of chord. Okay, because I've been given the midpoints. So that means I'm working in a right-angled triangle. Yes, Kumutsile, yes. OA is also absolutely, and if you wanted to, you could work in triangle ODA if you so choose, because OA is also going to be x plus 8. All right, so you could also work in triangle ODA in order to be able to solve for x. All right. Okay, let's continue. Now that we know that this is a right angle triangle, we are allowed to do the theorem of Pythagoras. So we say that dB squared plus DO squared is equal to the hypotenuse squared, which is OB squared. And we give our reason. We are saying this because of the theorem of Pythagoras. Again, we are going to substitute. We know that dB is 12. We know that DO is x. And we know that OB is x plus 8. So this is going to end up being a quadratic that we now need to solve. So 12 squared means 12 times 12. That gives us 144. Plus x squared is equal to, and here we have to multiply x plus 8 with x plus 8. We are squaring the binomial. We are multiplying it by itself. So now we're going to do FOIL on the right-hand side. So now that we do FOIL, we're going to go f, x times x is x squared. X times 8 is 8x. 8 times x is 8x, and 8 times 8 is 64. This x squared over here and this x squared over here are going to cancel one another out. Okay, so if I move the one on the right over to the left, it's going to be plus x squared minus x squared. So x squared is now gone. So what I'm going to do is I'm going to leave my x terms on the right-hand side. That gives me 16x. And I'm going to leave 144 on the left-hand side, and I'm going to bring the 64 over to the other side. Okay, so this means that I have 16x is equal to 144 minus 64. So I am left with 80. All right. And now the last step here, I need to divide by the coefficient of x. So I'm going to divide both the left and the right by 16. And that means that x is going to be equal to 5. That's it. Yes, good. Well done. Lovely, lovely, lovely. X is equal to 5. But I have not answered the question. I've solved for x. Remember, the question told me, all right, to calculate the length of OB. All right, they wanted me to work out the length of OB. So now that I know what x is, I've got to go back and sub it in. So in other words, I know that OB was equal to x plus 8. We've worked out that x is 5. So that means that OB is 13 units in length. And if you just wrote 13, that would be absolutely perfect. Okay, that's it. All right, so there we go. You can take a screenshot of that as well. And there are 2 examples for you. One on line from center, perpendicular to chord, and the other one on how we would use line from center to midpoint of chord. All right, so again, let's just check in with everybody. Once you've had a chance to catch up, how are we feeling? Are we all right? Okay. All right, lovely. Tapelo, you want me to scroll upwards? Oh, good. So everybody's feeling good here. Okay, is that enough, Tapelo? All right, I'm so pleased. Oh, good. I'm so glad. I'm so glad. So we've just gone through it very, very slowly, and hopefully everybody is okay. All right. Atabilile or Atabile, sorry. You wanted to ask a question. You're welcome to unmute. Atabile. Otherwise, I'm going to go back and continue. And Barley, I see you've got your hand up. If you want to ask a question, you're very welcome. Unmute and ask him, Barley. Just making these bigger in the meantime.
Okay.
Go for it. Okay, I'm going to continue because nobody's asking any questions. If you do want to ask something at any stage, that's absolutely no problem as well. All right, so here, this is the second section, all right, where we studied the angles on the inside of circles. So again, take some screenshots here to help you with this. All right, so these are the segment angle theorems. In other words, the angles on the inside of circles. All right, that's just a bit of an easier way to understand it. Okay, so in the first one over here, we have been given the bow tie. Okay, so the bow tie looks like this. It has 4 points on the circle. And what we would conclude here is that either angle A equals angle D, or we could use it to say that angle B equals angle C. So for both of those, we would use the reason angles in the same segment. I'm sure that rings a bell for all of you. Okay, so angles in the same segment. The next one, number 2, all right, we have been given a diamond head, and this angle over here is the angle at the center. So I'm going to color it in pink. This is the angle at the center. Okay, this angle over here is the angle at the circumference. All right, so here we say that the angle at the center is twice as large as the angle at the circumference. Okay, so angle at center is twice angle at circumference. I'm sure that rings a bell to a lot of you as well. Okay, angle at center is twice the angle at the circumference. Okay, so do not get confused between number 1 and number 3. Okay, a lot of students when they're in grade 11 get these two very muddled up. Okay, question or example number 1 and example number 3 are not the same thing. Remember, in number 1, for it to be angles in the same segment, all the points need to be on the circle. Okay, so all points are on the circle. Okay, here with, the angle at center is twice angle at circumference, we've only got 3 points on the circle. All right, the other point, if we could call it that, is at the center. So here the angle at the center is twice as large as the angle at the circumference. Okay, so that's angle at center is twice as large as the angle at the circumference. And then we can move those arms up even further. So what we've done here, so in other words, when we go from this diagram here in number 2 to this diagram here in number 4, we've taken this point B and that point C, and we've gone in this direction. We've raised them up and we've let them go higher up on the circle. That's why they're up here now. Okay, and again, the angle at the center is twice as large as the angle at the circumference. Okay, so again, there are only 3 points on the circle. The other point is at the center. So don't get confused with angle at center is twice angle at circumference. Okay, now I see there were a couple of questions. Unam, go for it.
Yes, ma'am.
Hello.
For number 3.
Yes.
Does it mean that the angle at the center is also equals to angle B, or angle at the center is equals to angle C?
No, not at all. Okay, so the angle at the center is not equal to B and it's not equal to C.
Okay.
Okay, all right, so B and C are not equal in example number 3. Okay, and they're also not equal to the angle at the center. The only thing we can say here is that this angle at the center, so in other words, this angle that has been created over here, okay, is 2 times bigger than that angle at A. Okay.
Okay, ma'am. Thank you very much.
It's a pleasure anytime. Atlechang, I see you've also got a question. You're welcome to ask.
Actually, I asked, ma'am. I'm the one who's been. Yes,
oh, okay. All right. Okay. No problem. All right. So I'm going to carry on. All right. So these are all things that we should be familiar with. We've obviously would have just forgotten them because we haven't done grade 11 in a little while. Okay. And then this is the next one. All right. So here in number 5, BC is a diameter. So that's this line over here. All right, and it subtends or creates or supports a right angle at the circle. So in other words, if BC is a diameter, it means BAC is equal to 90, and our reason is angle in a semicircle. Okay, so in other words, that angle over there is 90 degrees. All right, and then question number 6. Here, it doesn't matter whether B and C are joined with straight lines or if they are joined with a piece of an arc. If BC equals arc EF, it means that angles A and D are equal in size. Okay, so we would say that the angles are subtended by equal arcs, or the angles are subtended by equal chords. An abbreviation of that is equal chords subtend equal angles. You're also allowed to say that as well. Okay, it comes up occasionally. It is not very common, but we see it every now and again. Okay, so somebody just asked me to go back to number 4. Number 4 is like number 2 and also like number 3. So in other words, if we take our hands and we put our fingers, imagine if I could take hold of B and I could take hold of C in question number 2, and I could push those arms up to a higher point on the circle and then let it go, my arrowhead would become a diamond. Okay, so it's still a 4-sided shape. Okay, on the inside of my circle. Okay, not a cyclic quad, but a 4-sided shape on the inside, on the inside of my circle. Okay, so angles on the inside of circles, the ones we need to know are angles in the same segment, angle at center is twice angle at circumference, angle in a semicircle, and then this one, equal chords subtend equal angles. All right, now we're going to put that all together with what we already know. So let's have a look at the next example. Okay, so here we're just going to be working out the size of angles. So given AOC is a diameter, very important. When they tell us that AOC is a diameter, what are they trying to tell us? What does that mean for us? If AOC is a diameter, what does that mean for us? Can anybody tell me? You can put it into the chat. If AOC is a diameter, what does that mean for us? So with relation to our theorems, if they tell us that AOC is a diameter, then it means that they're trying to tell me something about one of the angles. Yes, that there is a 90-degree angle. Which one, Asunda? Which angle is 90? Which angle is 90? That's it, a corner. Quite right, the one at the circumference, 100%. Okay, so I'm just going to highlight this for you, and then I'm going to rub it out again because it's going to interfere with what we're doing. There is our diameter, and our diameter creates or subtends angle B at the circumference. So it is this entire angle here that is 90. B1 plus B2 plus B3 is 90. Okay, that's what it means for us when they tell us AOC is a diameter. The other bit of information that they give us is that B and D are 2 further points on the circumference. So we've got B over here and D over there, and they also tell us that angle A1 is equal to X. All right, write the following in terms of X. So here we have the same idea where we have to write things in terms of X. That's it, Luan, that's it. Fahim, quite right. What else is going on in this diagram? Well, let me rub this off and let's have a look at what else we can see here. What other kinds of angles are present? Well, straight away, I don't know about you guys, but I can see a bow tie. Okay, there it is. Over there, there's a bow tie. Okay, so because we can see the bow tie there, it means we've got angles in the same segment. So that means that angle B3 and angle A2 are equal. And it also means that angle D and angle C are going to be equal to one another. Okay. Something else I'm going to point out to you. All right. So in addition to angles in the same segment, all right, we have something that we saw in the first diagrams that we were looking at. All right. So here, OB is equal to OA. Can you see that? OB equals OA. Why? Why does OB equal OA? Exactly, Kumutsile. They are both radii. Okay, they are both radii. Absolutely. Okay, so Kamchelo, what did you want to ask?
Hi, ma'am.
Hi there.
My question was on our theorem on number 6. If whether we could use similarity to prove it.
No, you wouldn't be able to use similarity in this particular situation. No, you wouldn't. You wouldn't have enough information to be able to do that. Also, if they were working with arcs, it means that ABC and DEF are not triangles. Okay, remember triangles have got 3 straight sides. These have only got 2 straight sides. The other side is curved. Okay, so no, unfortunately, we wouldn't be able to use similarity. Then there was just one more question. Yunam, what was your question?
Ma'am, in the thingy where lines in the same segment, the two, how do I know which one are equals, which angles are equal?
In which way?
They ma'am, by DC and AB. Like, why didn't you? Why can't A and B be the angles that are equal because of the line in the segment? In the same segment. I just don't understand how to choose which ones are equal.
Oh, okay. All right. So in other words, what you've got to do is you've got to be able to see the bow tie. All right. So if we're drawing a bow tie, the only bow tie that exists here, this line from O to B doesn't form part of our bow tie. All right. Our bow tie, if we just go back up here and go and have a look, like I did in yellow over there.
Yes,
okay,
ma'am.
number 1, just like I did in yellow over there, the only bow tie that we can draw in this diagram over here, I'm going to draw it in yellow as well. All right, so here's our bow tie from A to C, from C to B, from B down to D, and then back here again. Okay, there's our bow tie. All right, so the line OB doesn't form part of the bow tie. Okay, the line AB doesn't form part of the bow tie.
Oh, okay, ma'am. Now I see. Thank you.
Fine. It's easier when somebody actually points it out to you. Okay.
Thank you, ma'am.
It's a pleasure. Now, before I took those 2 questions, I was also showing you, and someone asked, is OC also radius? And the answer to that is yes, it most certainly is. I was pointing out to you that OA and OB were equal to one another because they were both radii. What I'm trying to draw your attention to here, grade 12s, is the fact that OBA is a triangle. What can I say about angle B1? What is it equal to? So in other words, because OA and OB are radii, so in other words, this line segment here and that line segment there are equal, what can I say about B1? Absolutely, B1 equals A1, quite right, William. It's equal to X. Fantastic. All right, and can you see here, that's our first question. They want us to write down how big B1 is in terms of X. So in 3.1, we're going to say angle B1 is X. Now remember, every statement we make in geometry has to be substantiated, or another way of saying that is we have to give a reason. What is the reason that B1 is equal to X? And it's not radii. There's another reason that we've learned all the way back in grade 8 for the first time. Can anybody remember what it is? Yes, a corner, but we're not allowed to use the words isosceles triangle. Who knows why not, but they're not. There we go, Nolwazi, you're on the right track. So what we say here is angles opposite equal sides. Okay, angles opposite equal sides. That's it. Angles opposite equal sides. Okay, so B1 is also equal to X. All right. Now that we know that, they want us to work out what O1 is. Remember, we actually did a question just like that in the beginning when I was showing you how we would work out something that is in terms of X. So can anybody tell me what O1 would be equal to? If you can remember what we were saying earlier, how big is O1? Excellent. Okay, can you see that, guys? Nolwazi's got the correct answer straight away. All right, so O1 is 180 minus 2x. Lovely. Okay, so O1 is equal to 180 minus 2x. What's our reason for that? That's it, Charlotte. Right, 180 minus 2x. Okay, that is because the angles of a triangle sum up to 180 degrees. So again, that's another throwback from grade 8. Okay, so we can see here our grade 8 geometry, our grade 9 geometry is important for us in order to be able to do grade 11 geometry. All those things that we used when we were much, much smaller are now coming back. All right, so this is 180 minus 2x. Very good, well done. Okay, so in other words, Lusanda, if you add x and x together, you get 180. All right, so what we did here is we said angle O1 plus angle A1 plus angle B1 gives us 180 degrees because of the angles of a triangle. Okay, O1 is what we want to write, what we want to work out an expression for. A1 is x, B1 is x. So now when I take these two x's over to the other side, it's going to be 180 minus x, which is minus 2x. That's where it comes from. Okay, so that's the explanation. Okay, behind this one. Now they want angle C. So again, in geometry, work from what you know to what you don't know. Always work from what you know to what you don't know. All right. So now that we've done O1, what is the relationship between O1 and C? Can anybody see that? The relationship between O1 and C. Okay, I'm afraid, okay, O2 would be exterior angle of the triangle. All right, now what I want everybody to do is this. I'm going to highlight, I'm going to get rid of all of this. Okay, it might be a little bit difficult to see, okay? And what I'm going to do is I'm going to make this even bigger. Let's see if I can make this a little bit bigger. Sorry, that's your homework, work for you to try. Okay, I'm going to make it a bit bigger like that, okay? Everybody put your fingers at A and B on your screen. Put your finger at A and B. So from A and B, follow the lines to O. That's the angle at the center. So O1 is the angle at the center. Go back to A, go back to B, and now go past O and along B to C at the circle. Okay, so again, you've got your finger at A, your finger at B. You're going to go along AO to O, along BO to O. That is the angle at the center. Okay, so O1 is the angle at the center. When we go back to A and B, we're going to follow the lines to C at the circumference. So in other words, what we've got here is the angle at the center is twice the angle at the circumference. Okay, O1 is twice as big as C. That's right, Nolwazi. O1 is 2 times C. Yes. Okay, so now we're going to substitute. All right, so for 3 point, we're going to have to say goodbye soon. All right, O1 is twice as big as angle C. Angle at center equals 2 times angle at circumference. Okay, so if O1 is equal to 2 of C, I wonder if I can move this down. Oh, sorry guys, I can't. That's a little bit irritating. Let's just write over here. Okay, so O1 is twice as big. So O1 is 180 minus 2x, and that is equal to angle C, but it's 2 of angle C. So I'm going to divide by 2 here. So I'm going to divide by 2 over there. So that means that angle C is going to be equal to 180 over 2, which is 90, minus 2x over 2, which is 90 minus x. Okay. No, C is not equal to 90. C is equal to 90 minus x. Okay, because it's half the size of O1.
Well done, Michelle.